In the rapidly evolving realm of artificial intelligence, vast data centers power the models that reshape how businesses and industries function. Among the latest breakthroughs stands Retrieval Augmented Generation, simply known as RAG, a method that bridges large language models with access to real-world knowledge. Unlike standalone language models, which rely solely on internal parameters trained from internet-scale data, RAG systems dynamically connect models to external databases in real time. Traditional models generate responses based on what they have seen during training. Their knowledge becomes frozen upon deployment. A RAG pipeline. A user input flows into a split system, one path to a retrieval engine, the other to a generation model. RAG introduces a retrieval component. When a query arrives, the system first searches vast knowledge libraries, be it enterprise documents, up-to-date scientific articles, or even real-time news feeds. The retriever identifies the most relevant pieces of data from the external corpus, filtering noise and surfacing only the most pertinent information. The generator then synthesizes this retrieved content with the original question, crafting richer, more accurate, and contextually aware responses. A business analyst querying a corporate chatbot about regulatory policy changes. The chatbot retrieves new legislation from an up-to-date database before answering. This capacity empowers AI to answer questions about emerging topics, going beyond the knowledge cutoff inherent in static models. Montage. Medical research assistant leverages RAG to find latest studies. Legal AI advisor retrieves recent court decisions. In high-stakes fields like medicine, law, and finance, timely information is critical. RAG systems democratize access to the freshest, most authoritative data. Technically, many RAG architectures employ vector search with dense embeddings. The model translates text into mathematical vectors for lightning-fast semantic matching. Narrator. Retrieval can be fine-tuned, using traditional TF-IDF, smart neural encoders, or domain-specific signals to improve precision and recall, depending on the challenge. In financial services, RAG enables virtual analysts to deliver the latest insights, detect discrepancies, and support compliance, all in the right context. By showing cited passages alongside generated text, RAG systems allow users to trace conclusions back to real sources, critical for trust and transparency. Digital journalists use a RAG tool to fact-check election data live. Journalists, researchers, and analysts now depend on these systems to cut through information overload, finding needles in ever-growing haystacks. AI model struggles with a query about a new medical drug launched last week. It finds nothing. A RAG system, however, retrieves reputable clinical trial reports from a constantly updated archive. Traditional models are inevitably outpaced by new information. RAG is designed for adaptability, sustaining AI's relevance as knowledge grows. A global supply chain manager's querying shipment trends, interfacing with a RAG-powered platform. RAG enables intelligent workflows, clarifying ambiguous instructions, offering the latest compliance steps, and handling nuanced, domain-specific queries. A dashboard comparing static LLM accuracy versus RAG system accuracy over time. Recent studies show that RAG systems consistently outperform static models on both accuracy and user satisfaction, especially in knowledge-intensive scenarios. A developer reviews error logs and fine-tunes a retriever's parameters. Like any system, RAG architectures require careful tuning, robust data hygiene, and constant evaluation to prevent retrieval errors and hallucination. Security officers monitor data access logs in a control room. Privacy and governance must be addressed, ensuring that retrieval privileges align with corporate policy and legal constraints. AI engineers run stress tests on RAG platforms under heavy concurrent load. Scaling RAG for enterprise relies on hybrid indexes, caching strategies, and judicious trade-offs between efficiency and retrieval quality. Open source and commercial RAG frameworks are reviewed side by side on screen. A new wave of infrastructure tools, both open and proprietary, accelerates adoption, giving teams flexible blueprints to deploy RAG at scale. One promising frontier: retrieval over private, siloed knowledge, training assistants that learn, adapt, and update from an organization's living documents. CIO elaborates on the impact for digital transformation. Smart enterprises are investing in RAG as a competitive differentiator, augmenting both human expertise and machine automation. A customer support bot retrieves latest troubleshooting steps from an evolving FAQ database. The end result: AI that offers better answers faster, with visible cited evidence that users can trust. The technical dance between retrieval and generation is at the heart of next-generation knowledge work, blending efficient search with the fluency of natural language understanding. A training workshop for IT professionals who experiment hands-on with RAG-enabled tools. Understanding RAG's mechanisms, limitations, and opportunities is now essential for AI architects, developers, and decision-makers building knowledge-centric applications. As our world's collective knowledge expands, Retrieval Augmented Generation ensures that AI systems remain insightful, up-to-date, and relevant, powering the relentless march of innovation.